Hi there, welcome again. We're looking at internal resistance in the topic of electricity. Here we have a very basic example of application of internal resistance. And notice the circuit, and in the circuit what we have as the current flows here, we've got the current coming, we've got the total current leaving the battery, and as it comes along here we notice that the total current is flowing into R1. Then it continues past all the way to here, and then the current splits up into two resistors, or into two branches, and it goes again, but it comes, one goes through R2, one part of the current goes through R3, and then the total current meets us this point again together to come along, and we notice that the battery is the switch is open. Okay, so we're obviously assuming the switch is closed as I'm following this total current, and then the total current is passing through the ammeter. That's important to know, that the ammeter is measuring the total current in the circuit. Then as we come back to the battery, we notice something peculiar. This strange diagram, which I showed you in the previous video, demonstrates that there is internal resistance in the battery. So we notice this internal resistance. Now let's quickly read what they tell us about the circuit. In the electric circuit shown below, the battery has an EMF of 9 volts. Okay, so if we were to read on the battery how much the voltage is it supplies, it will tell us 9 volts. The EMF is equal to 9 volts. That's also the voltage we would measure while the circuit is open. And an internal resistance, oh, that's great of them. They've given us the internal resistance is 0.7 ohm. That is the resistance of this battery. The total external resistance of the circuit is 15 ohm. So 15 ohm is the total external resistance, and that is also called the load. So the load of the circuit is 15 ohm, and we use a capital R to represent that. Okay, calculate the current in R1 when the switch is closed. So the switch is closed, and when it's closed, the total current will pass through R1. Now that's very simple, okay, because we know that total current is equal to total volts, which is called EMF, divided by total resistance. Now total volts we know is EMF, and total resistance is the load plus internal resistance. I didn't show it here, but internal resistance represented by lowercase r. So the total exterior resistance, all of these together, is 15.1, and internal resistance is 0.7. So EMF of the battery is simply 9 volts divided by the total resistance in externally is 15.1 plus internal resistance 0.7 to give me a total of 9 volts divided by 15.8, which is going to give me a final answer of 9 divided by 15.8 is 0.569. So 0.5, I like to have again, when 3 significant digit after the comma, if there is nothing in front of the comma, then I think 3 is fair. But even if I do 3, it's going to turn it to 0.569. 69 will become 70, so it will only be 0.570, and I can leave out the zero, the trailing 0 after the commas. Okay, that is the total current that we will encounter passing out of the battery and into R1. That's an easy question. Thank you for watching.